Let's do checkpoint 6.12. Here they want us to look at this vector field to see if it's conservative. This g is equal to y comma x comma xyz. There is a theorem called the cross-partial property of conservative vector fields that tells us that if we have a vector field g, which is equal to three functions in each of these components, some p function, a q function, and an r function. These are functions of three variables. This is conservative if three things hold, and the first one is the partial of p with respect to y is equal to the partial of q with respect to x. The second, partial of q with respect to z is equal to the partial of r with respect to y. And then finally, the partial of r with respect to x is equal to the partial of p with respect to z. If all these hold, then our vector field is conservative. For our purposes, or for our vector field here in particular, our p function looks like it's just the function y, our q function looks like it's x, and our r function is the product x times y times z. So let's check the three criteria. For the first one, we want to know what the partial of p with respect to y is equal to. Partial of p with respect to y is 1. The partial of q with respect to x is also equal to 1. So it looks like we're off to a good start here. Our second one is the partial of q with respect to z, and that looks like it's going to be 0. Partial of r with respect to y looks like it's going to be xz. So already here we can stop and say does not meet criterion, and we don't have to check the third one. We can just stop and say, well, we're done. Our conclusion is that the vector field G is not conservative. And then that's it. If this were true, then we can check that last one, and then we can have that decide whether it's conservative or not. But we're here, we're done, and I hope that helps.